Good afternoon, children. Welcome to SBRPUC online chemistry classes. As we have started in the last class, chemical properties of hydrocarbons, that is, chemical properties of alkanes. Let us continue from the same. Alkenes. You may be remembering that one of the chemical property we have completed in the last class, related with what, children? Halogenation. In the halogenation, as I said that for the 2 marks question will be going to raise for the chlorination of methane. As in presence of diffuse sunlight, or we can write even as a photochemical reaction also, at high temperature, what happened? One by one hydrogen atom of alkane are replaced by halide group. Like that, methane can be converted into carbon tetrachloride. Methane can be converted into carbon tetrachloride. In that only we are having 3-mark question. 3-mark question, very important question. Mechanism of chlorination of methane. Mechanism of chlorination of methane. Chlorination of methane. What is mechanism and all? Everything I'll tell you once you listen here. Total in alkane, like in alkane, we are having one mechanism. In alkene, we are having the 2 mechanism. Like that, totally 3 mechanism are there. From this, one mechanism is fixed in exam. In case of the alkane, in case of the methane, as we said in the previous class, that whenever we are going to produce, the produce alkyl halide from haloalkane, like CH4 on chlorination in presence of diffuse sunlight converted into methyl chloride. Further methyl chloride on further chlorination in presence of diffuse sunlight to convert it into dichloromethane. Same condition, we can get it as a trichloromethane. Same condition has to be maintained to get carbon tetrachloride. This reaction already have completed in the last class for 2 marks. This complete reaction they'll ask in the exam for 2 marks. But mechanism they will ask in the exam for 3 marks. That mechanism we are going to discuss now. What is that mechanism? Mechanism is nothing but systematic study of a reaction or stepwise reactions involved to convert reactant to product. They are called as mechanism. And the mechanism involve 3 steps. Okay, mechanism involve 3 steps. 3 steps are going to be involved over here. Then step 1. Step 1 is called as chain initiation. Step 1 is called as what, children? Chain initiation. Initiation name itself indicates that you are going to initiate or you are going to start up the reaction. You are going to start the reaction. And during this reaction, when methane undergoes chlorination, already as I said to you, it is a type of free radical mechanism. It is a type of what? Free radical mechanism. Free radical mechanism. We know very well that free radical will be most reactive till they combine. 2 free radical are going to combine to form a molecule. Till then reaction are going to be proceed. Then what happened in the chain initiation? When chlorine molecule in presence of diffuse sunlight will produce chlorine free radical with chlorine free radical. With a different color I will represent here, children. Chlorine free radical and chlorine free radical. It is called as what? Chlorine free radical. Free radical. Chlorine free radical. So here in the chain initiation, what happened? They are going to produce chlorine free radical. They are going to produce chlorine free radical, and it is a type of what? Homolytic fission. It is a type of homolytic fission. Homolytic fission, as we said in the earlier topic, that homolytic fission where there is an equal distribution of electron takes place. And the step 2 is chain propagation. Step 2 is what? Chain propagation. Chain propagation. Chain propagation. How the chain propagation are going to take place? Let us see, children. I'll write here. In the chain propagation, chlorine free radicals are generated. They are going to combine with methane molecule. As they will start proceed with the reaction, free radicals are going to form. And remember here, always the propagation involve more than one step. Always propagation involve more than one step reaction. That is methane with chlorine free radical will produce methyl free radical with HCl. We'll get it as methyl free radical with HCl. And this methyl free radical with chlorine molecule. With what? Chlorine molecule. Again, the reaction are going to be like a chain reaction, never ending reaction. Till they get a neutral molecule, they are going to combine again and again. We'll get it as what, children? We'll get it as methyl chloride along with chlorine free radical. Then this methyl chloride again with chlorine free radical are going to combine. Here methyl chloride with chlorine free radical. So here we'll get it as what, children? We'll get it as CH2 because one of the hydrogen atom is replaced by what? Chlorine. So we'll get it as CH2Cl. Correct? So remember here, when we are getting a CH2Cl, it will be produced as a free radical, then CH2Cl and this chlorine, because we are going to get H and the Cl over here. That's why they are going to produce HCl. They are going to produce what, children? They are going to produce HCl. CH2 dot is called as methylene. CH2 dot is called as methylene free radical. Then methylene chloride free radical again combine with chlorine molecule. This reaction, as I said, that they are not going to combine. They are not going to sit quite till they are going to produce what? A final product. When they are going to combine over here, again we'll get it as CH2Cl2 with chlorine free radical. All the free radical I have represented with a different color. It will be easy for you to identify. And so on. All these reactions are what? Chain reaction. As these reactions are chain reaction, never end. So here in the chain propagation, what happened? Chlorine molecule on homolytic fission will produce chlorine free radical are going to be produced. Same way, chlorine free radical, this is the free radical, chlorine free radical with methane will produce methyl free radical with HCl. Then methyl free radical with chlorine molecule will produce chlorine free radical. That chlorine free radical with methyl chloride, again it will produce methylene free radical. Then methylene free radical are converted into dichloromethane. Similarly, and so on reactions are going to produce. Similarly, we'll get trichloromethane and carbon tetrachloride. Instead of writing that in the theory paper, you can write all these amongst these 3, 4. If you are writing 2, 3 also, it is more than enough. But need to write that similarly, all are going to produce the reaction as further as trichloromethane, carbon tetrachloride. But remember here, every reaction is involving one or the other way free radical. And those free radicals are very reactive species. They are highly reactive. That's why those free radicals are going to combine to form a neutral molecule and reaction has to be stopped. It is called as chain termination. Called as what? Chain termination. I'll write here. in step 3. In step 3 called as chain termination. Chain termination. In chain termination, what happened, children? All the free radicals are going to be combined. All the free radicals are going to combine to form a neutral molecule. Chlorine free radical with chlorine free radical combine to form chlorine molecule. Form chlorine molecule. Methyl free radical with methyl free radical. Methyl free radical with methyl free radical. Both are in the form of a free radical. They will produce what, children? Ethane. CH3, CH3. Same way, methyl free radical with chlorine free radical. Methyl free radical with chlorine free radical are producing methyl chloride, and so on. That means that in the chain termination, reaction has to stop. Two free radical are combined to form a neutral molecule. Two free radical are combined to form a neutral molecule. That means that we are going to end up the reaction. Let me repeat here the mechanism. Look at over here. The mechanism involves 3 steps, we said. We said that in the chain initiation, reaction has to be started. How the reaction can be started over here? Chlorine on photochemical reaction are produces chlorine free radical. And these chlorine free radical are very active. They are paramagnetic in nature, as we said. They are reactive species. They combine with methane to form methyl free radical with HCl. Then methyl free radical, again radical will be very active. Again they react with chlorine molecule to form a chlorine free radical and methyl chloride. Methyl chloride. Then that methyl free radical further with chlorine molecule form methyl chloride and chlorine free radical. Chlorine free radical with methyl chloride, again it will produce methylene free radical. Again methylene free radical with chlorine molecule to get a dichloromethane, trichloromethane, but everywhere you are getting a free radical. Those free radical has to combine to form a neutral molecule in chain termination. This is the very important mechanism, children. Every step carries one mark. Chain initiation 1 mark, propagation 1 mark, and termination 1 mark. In the termination, what happened? Every free radical are combining to form a molecule. Chlorine free radical with chlorine free radical form chlorine molecule. Methyl free radical with methyl free radical produces ethane. Methyl free radical with chlorine free radical produces methyl chloride, and so on. So reactions are going to be continued. Till you get a final product, reactions are going to be continued. Okay, this is all about the mechanism of chlorination of methane. As I said that reaction will last for 2 marks, but the mechanism they last 3 marks. Mechanism is most expected in the theory paper, but in the MCQ exam, in MCQ they will ask the question related with which type of fission it is, homolytic fission, and here free radicals, which reactive intermediate are going to be generated, free radical are going to be generated. And free radicals are very active species. That's why reaction can be proceed. But remember here, free radical can be done only in presence of sunlight. Only in presence of water, sunlight. The next is water related with children, related with second type of the reaction, that is combustion. This is all about the first one. Now let us move to the second type, second chemical property, that is combustion. Second one, combustion of alkane. Combustion of alkanes. Combustion means what? Burning in presence of air or oxygen. Burning in presence of air is called as combustion. And here always combustion is exothermic phenomena. Whenever the hydrocarbons undergoes combustion by burning in presence of air or oxygen, They will produce carbon dioxide gas with water and delta H will be negative. Delta H is negative. That means that reaction is exothermic. Reaction is what, children? Exothermic reaction. Exothermic reaction. Exothermic reactions are one where heat is liberated, and because of this reason hydrocarbons are used in fuels. Hydrocarbons, because fuels are composed of what? Hydrocarbon, because they will release here enormous amount of heat energy. That energy can be utilized for the different purpose. That's why it is called as combustion. When hydrocarbon undergoes combustion, as we are taking the topic related with alkane, we are taking the example as alkene. Alkane are represented by the general formula CnH2n plus 2 on combustion. On combustion, later we'll balance equation. That's why I'm leaving space. Converted into water, converted into carbon dioxide and water. Converted into water, carbon dioxide and water, and amount of heat energy released over here as minus x kilojoule per mole. X kilojoule per mole. X will be different for different hydrocarbons. That's why we can take it as N of CO2 CnH2n. 1 minute. Cn H2n plus 2 plus, okay, CnH2n plus 2 we said, will get it as N of CO2, and H2O will get it as N plus 1. H2O is how much, children? N plus 1 H2O. Therefore, how much will be F? This will be left out. This we are going to take. That's why it will be 3N plus 1 divided by 2. We have to write the general equation, but for this one I have given conveniency. We can go directly to the example. Like the example, methane on combustion in presence of air or oxygen by heating at a high temperature, it will produce carbon dioxide and water. Balance the equation. 2 hydrogen we need, 2 plus 2, it will become it as a 4. And the delta H will be minus 890.5 kilojoule per mole. It means that by the combustion of 1 mole of methane, by 1 mole of methane produces, how much heat energy is going to be released? 890.5 kilojoule per mole of heat energy is released. Released is nothing but what? This much amount of heat energy is going to be liberated out, and that energy can be used as for different purposes. That's why we'll say that when methane undergoes combustion, any hydrocarbon when they undergoes combustion, they are going to release carbon dioxide along with the formation of water. Along with the formation of water, heat is released. That's why it is called as exothermic reaction. Called as what? Exothermic reaction. Heat evolved, during which heat is evolved. Heat is what, children? Heat is going to be evolved. That's why it is called as exothermic reaction. Another point we can remember that if it undergoes incomplete combustion, if hydrocarbons undergoes incomplete combustion, this is a complete combustion in presence of water. It is a complete combustion in presence of air or oxygen. If it is a incomplete combustion, if incomplete combustion are going to take place, if it is an incomplete combustion, then it will produce carbon black. It will produce what? carbon black. So it means that when it undergoes incomplete combustion, if methane undergoes incomplete combustion, it will produce carbon black. Carbon black. And this carbon black is used for paints, ink, even for the painter ink or the black pigment. It is used in black pigment, paint, or even we can call it as ink. There are the different purpose of using carbon black. That means that when methane undergoes complete combustion, we are going to get carbon dioxide and water with the liberation of enormous amount of heat energy. Whereas if it undergoes incomplete combustion, if it is an incomplete combustion, it will produce carbon black, or we can call it as what, children? That carbon black can be used in the black, this one paint, or we can use it as a black pigment, or even it can used in ink. This is the main application of combustion, incomplete combustion of methane. Complete combustion will produce as what, children? It will produce enormous amount of heat energy. Because of that reason, hydrocarbons are the best fuel. Hydrocarbons are what, children? They are the best fuel. They are called as best fuel. So here, when we are dealing with the hydrocarbons, another point we can see that these are the two properties. One property related with halogenation, and the second property related with what, children? It is related with combustion. Different reactions still they are possible, because hydrocarbons are paraffins, we said. When we are saying it as a paraffin, the reactivity will be low. Means properties will be exhibited by these hydrocarbon, or the saturated hydrocarbons will be less. Now we'll see controlled oxidation. Means what is the meaning of controlled oxidation? Because when we are proceeding oxidation, different oxidizing agent will produce different product. What are those? That we'll see one by one, children. Controlled oxidation, Roman number 3. I'll write here. Controlled oxidation. Any of the number you can write, urban number, Roman number, star mark. Controlled oxidation, third property. Controlled oxidation. Alkane undergoes oxidation by using different oxidizing agent. We can use oxide of molybdenum as a oxidizing agent. Even we can use, because removal of hydrogen and addition of oxygen is also called as oxidation. Methane, on oxidation by using copper. Copper can be act as removal of oxygen, addition of oxygen, and removal of hydrogen is also called as oxidation. Therefore, at 523 Kelvin, 100 atm pressure. Remember here, temperature and pressure parameters. If it is a slightly plus or minus, no issue at all. It will produce methyl alcohol. When what I said, that controlled oxidation is one, where different oxidizing agent are going to produce different product. Here we'll get it as what? Methyl alcohol. As I said earlier, here we can write methyl alcohol, whose IUPAC name is methanol. Methyl alcohol. When methane undergoes oxidation, balance the equation. If I'll take this 2, this will also be taken. It has 2, 2 4s are 8. It will be, oxygen will be 4, 4 2s are 8. So here when it undergoes oxidation, by using copper at 523 Kelvin and 100 atm pressure, they are going to produce methyl alcohol. They are going to produce what, children? Methyl alcohol. Same way, if we are going to take a methane on oxidation by using oxide of molybdenum, okay, or we can use this as MO2 O3. Molybdenum oxide also we can write. In some of the text, we'll get it as directly oxide of molybdenum. By heating, what happened? By heating this one, we'll get formaldehyde. Formaldehyde, which is also called as methanol. IUPAC name is methanol, AL. This IUPAC name is methanol. Alcohol is OL. Aldehyde is AL. Along with water. Along with what, children? Water. So here we can say that when we are going to proceed the oxidation in presence of oxide of molybdenum, we are going to get water. We are going to get it as a formaldehyde. If we are taking in presence of manganese acetate, we'll get it as respective carboxylic acid. Respective carboxylic acid in what sense? If I am going to take ethane. Ethane on oxidation in presence of manganese acetate. What we can say? Ethane on oxidation in presence of manganese acetate, it will produce acetic acid plus water. Acetic acid called as ethanoic acid. Called as ethanoic acid. Is it balanced equation? 3 plus 2, 1, 4, 4 plus 2, 6. 2 oxygen are there. Oxygen, is it a balance? You look it over there. We are going to get it as a water. This one. If we'll take this as a 2, this will also be 2. This will also be 2. Correct? So here we'll get it as a 2. Oxygen, how many we need? Carbon, hydrogen also balance. 6 2s are 12. 12, 4, 4 2s are 8. 8 plus 4 will be 12. Oxygen only has to be balanced. 2 2s are 4. 4 plus 2 is 6. This I'll take it as 3. Correct? Ethane converted into what, children? Acetic acid. How many number of carbon atoms are there? We are going to get the same number of carbon atoms. You may be thinking that, but for the 2 example, I have taken methane. Why I have not taken over here? Correct? Correct. This one, we can say that when methane are converted into formic acid, quickly they'll decompose to get a carbon dioxide and water. That's why we are not preferring methane. Whereas if we are going to take, this is all about the methane and ethane. If we are going to take with respect to other chain of isomer, like if we are going to take CH3 thrice CH. How will you name this one? CH3 thrice CH, CH, CH3, CH3 and CH3. Correct? Longest chain will be propane. We can call it as 2-methyl propane. Okay, 2-methyl propane. and concentrate here, carbon is containing only one hydrogen, 2-methyl propane. 2-methyl propane, when it undergoes oxidation by using what, children? Potassium permanganate. When it undergoes oxidation by using potassium permanganate. Potassium permanganate, KMnO4, is a best oxidizing agent. What happens? It will get it as CH3, CCH3, CH3 as OH. Tertiary butyl alcohol. Tertiary butyl alcohol. I'll write here beside to this. Tertiary butyl alcohol. Tertiary butyl alcohol. Is it visible, children? Yes. Okay. Tertiary butyl alcohol. So here when we are taking with respect to, because carbon atom, nature of the carbon atom, as I said in the previous class, carbon with 3 hydrogen are primary, carbon with 2 hydrogen are secondary, carbon with 1 hydrogen are tertiary. Therefore, this carbon atom is what, children? Tertiary carbon atom. It is the nature of tertiary carbon atom. So tertiary carbon atom are converted into tertiary butyl alcohol when they undergoes oxidation with potassium permanganate. So here open chain hydrocarbon, that is a saturated hydrocarbon alkane, will show different controlled oxidation. One with the copper will produce methyl alcohol, with oxide of molybdenum will produce formaldehyde, whereas with manganese acetate produce acetic acid, whereas by taking potassium permanganate, this is only for the molecule containing tertiary carbon atom. Containing what? Tertiary carbon atom. It will produce tertiary butyl alcohol. Okay. First property we have done, halogenation, and the second property combustion, and the third property is controlled oxidation, and the fourth one is isomerization. Isomerization. Name itself indicates that molecule are isomerized. You may be remembering that in the previous class, as I said, that all the carbon atoms are arranged in an open chain. They are called as normal chain. One of second carbon atom are substituted by alkyl group called as iso. Third carbon, it is called as secondary. All the carbon atoms are branched. They are called as neo. These are the branching are going to be takes place. Isomerization means what? Open chain hydrocarbon are converted into respective isomer. So here different probable isomers are possible. Different probable isomer where straight chain hydrocarbon when heated with, when we are heating with water, aluminium chloride in presence of dry HCl, alkane, heated with aluminium chloride, AlCl3 in presence of dry HCl, in presence of dry hydrochloric acid or the dry HCl at about, remember here, when we are doing at high temperature at about 573 Kelvin and 35 atm of pressure, they are going to convert it into water, isoalkane. Isoalkane. This general representation I have given. Will go to the example. For example, if we are taking CH3, CH2, CH2, CH3. What it is? Normal butane. All the carbon atoms are arranged in open chain. They are called as normal butane. When isomerizes in presence of AlCl3 and dry HCl at a particular temperature and pressure, they are converted into isobutane, CH3, CH3 and CH3, called as isobutane. isobutane. Normal butane is converted into isobutane by isomerization in presence of AlCl3, dry HCl at a particular temperature and pressure. Now you may think that instead of taking butane, if I'll take pentane, what happens? That example also will take, because in the NCERT text they said they have given for butane, but they have asked to children to write for pentane. CH3 CH2 CH2 1 2 3 4 5 normal hexane. It will produce what, children? 1 2 3 4 5 6. Carbon atom number 1, second. You write yourself 2-methyl hexane. 1 2 3 4 5. 2-methyl pentane. One more possibility, that 1 2 3 4 5 6. 1 2 3 4 5 6. 1 2 3 4 5 and 6. 3-methyl hexane. 3-methyl hexane. Different isomers at different temperature are going to be possible. 1 2 3 4 5 6. Carbon atom number 1 2 3 4. Different isomers are possible. Only the thing is that parental chain are going to be changed. That's why it is called as isomerization. It is called as what, children? Isomerization. Therefore, isomerization is one where number of chain isomers are going to be different. In here, normal are converted into iso can be converted into neo or the tertiary. Many of the branching are going to be occur in such a way that different chain probable isomers are obtained when normal chain are isomerizes with AlCl3, dry HCl at a particular temperature and pressure. The next is even this one, the normal chain hydrocarbon have a character to undergo cyclization. Cyclization, even they can produce what? Benzene as an aromatic hydrocarbon. That's why it is called as aromatization. The fifth one. Fifth one is aromatization. First reaction, halogenation. Second, combustion. Third, controlled oxidation. And the fourth, isomerization. And the fifth is aromatization. To get a benzene ring, minimum open chain hydrocarbon must have how many carbon atoms? They should have 6 carbon atoms. Correct? Minimum they should have 6 carbon atom. Therefore, 6 carbon atom chain, 6 carbon atom or the more than 6 carbon atom, when they are heated with oxides of vanadium or the chromium or the manganese. Say 6H14. It is a normal hexane. Normal hexane. On aromatization by using chromium oxide, because what I said that we are going to use either oxide of chromium or we are going to use oxide of molybdenum also, vanadium also, Cr2O3 or V2O5 or MO2O3, any one of these. Normal hexane can be converted into cyclohexane. Cyclohexane, which on further heating removes hydrogen. Cyclohexane is C6H12. C6H12 converted into benzene. So minus of 3H2. Minus of what? 3H2. Instead of writing this intermediate, directly we'll write that normal hexane are converted into cyclohexane, cyclohexane to benzene. Instead of writing two-step, directly we can write the conversion that normal hexane can be converted into benzene, 6-membered ring or more than 6-membered ring. If, for example, I'm going to take it as normal heptane, same conditions are going to be maintained. We'll get it as a benzene with one of the hydrogen is replaced by methyl group called as toluene. Called as what? Toluene. So it means that whenever they are undergoing substitution reaction, whenever they are undergoing aromatization reaction, open chain hydrocarbons are converted into aromatic ring compound. They are called as aromatization. They are called as what, children? They are called as aromatization. And the last is action with steam. Fifth one. Fifth one. Action with steam. Water vapors are called as steam, children. Water vapors are called as steam. When methane undergoes steam reaction in presence of nickel, methane with the steam, water vapors in presence of nickel, in presence of catalyst, we'll use here, children, nickel at about 1273 Kelvin. At about 1273 Kelvin, it will produce the mixture of carbon monoxide and hydrogen. Because 6 are there, 3 2s are 6 carbon. And this is actually the commercial method. This method is commercial method to manufacture dihydrogen. To manufacture dihydrogen. To manufacture dihydrogen. This is a commercial method. Methane, on passing through the steam by using nickel as a catalyst at about 1273 Kelvin will produce the mixture of carbon monoxide and hydrogen. It will produce what? Carbon monoxide and hydrogen. And this is one of the best method for the commercially manufacture of hydrogen gas, for the commercial manufacture of dihydrogen gas or hydrogen gas. This is all about chemical properties of alkane. Let me revise from the starting, children. I'll take the slide from where we have started. In the last class, we have done substitution reaction. And during the substitution, already I said to you this also. That is, in the substitution reaction, what happened? One of the hydrogen atom replaced by halide, and it is a chain reaction. One by one hydrogen atom are replaced by halide group. Then in the mechanism, we said that it is a free radical mechanism and it is a homolytic fission. As we said that it will involve homolytic fission. It will involve homolytic fission and it is a free radical mechanism where free radicals are going to be generated in presence of sunlight, or even at high temperature also it is possible. Chlorine on free radical substitution will produce chlorine free radical. Then in the chain propagation, where more than one step are possible, methane with chlorine free radical will produce methyl free radical. Methyl free radical with chlorine molecule gives chlorine free radical. Again, chlorine are going to combine, and so on reaction are proceed. In the chain termination, all the free radical are combined to form a neutral molecule. Then the reaction are going to be end up. Initiation, propagation, termination, every step carries 1 mark. And the second reaction is what? Combustion of alkene. When alkane undergoes combustion, any hydrocarbon, not only alkane, any hydrocarbon, when they undergoes combustion, they will produce oxide of carbon and oxide of hydrogen. So here, and this combustion is exothermic reaction. Enormous amount of heat energy is going to be released. Because of that reason, hydrocarbons are used as a fuel, and that whatever the energy is going to be released, it is used for automobile, or we can say that for different purpose. When they undergoes combustion, they are going to release, for example, the methane will, 1 mole of methane will produce 890 approximately kilojoule of heat energy is released. But if it is an incomplete combustion, they are going to produce carbon black. Whereas in the controlled oxidation, what we said, different agent will produce different product. For example, the copper at 523 Kelvin and 100 atm will get a methanol. Molybdenum oxide will produce methanol. Then manganese acetate will produce acetic acid, whereas the tertiary carbon atom must be tertiary, means carbon should contain only one hydrogen atom. Tertiary carbon with potassium permanganate will produce tertiary butyl alcohol. And the next we said that isomerization, with the normal chain are converted into isomer. Normal chain are converted into isomer. Similarly, in the aromatization, open chain hydrocarbons are converted into cyclic hydrocarbons. They are converted into what? Cyclic hydrocarbon or aromatic hydrocarbon. It means that molecule should contain minimum 6 carbon atom or more than 6 carbon atom. Last one is reaction with steam. When methane with steam, they are going to produce hydrogen. And this is one of the best way to manufacture what? Hydrogen for commercial purpose. For commercial purpose. Correct? Now we'll move to what, children? Conformation. One word they have mentioned in NCERT related with what, children? Conformation of alkenes. Achha, one more, this one, pyrolysis. So here this is all about what, children? What I said, that how many reactions we have completed? 1 minute. 5 we have completed. Yes. 5 we have completed. Last one more. Pyrolysis. Pyrolysis means breaking. Breaking means what, children? Higher hydrocarbon are converted into small fragment when they are going to heat at high temperature. When they are going to heat at what, children? High temperature. During at high temperature only, all these reactions are going to be produced. Do you know that by the free, this is what? This is also a free radical mechanism. This is also a free radical mechanism. Here, petrol. From the petrol, we are going to get all gas oil. That means that one of the best method to convert higher hydrocarbon into lower hydrocarbon. One of the best method to convert higher hydrocarbon into lower hydrocarbon. For example, hexane, C6H14. It is hexane when we are heating at a high temperature. When we are heating at a temperature, high temperature, around 773 Kelvin. A different temperature will get a different fragment. C6H14 converted into C6H12 with the liberation of hydrogen gas. Both are the smaller component are going to be produced. Smaller component are going to be produced. Even it can produce butane and ethane. C4H8 plus C2H6. C2H6. Even it can produce because C4C6 it will become. If I am going to take C3, I'll take it as 6. Propene we can take. Propene, then the 6 carbon atom, 3 are there with H8. Propane and propene. Propane and propene. Same way, if we are going to get ethene, C2H4, we'll get it as a water C4H, how much? 10. It means that higher hydrocarbon, all these are what? Normal hexane. Normal hexane. Same way, if you are taking a 10 number of carbon atom, we'll get 8 plus 2. Correct? 6 plus 4. That means that number of carbon atoms, 6 are there, 4 plus 2 will be 6. Same way, 3 plus 3 will be 6, 2 plus 4 also 6. One is a alkane, one is a alkene. So remember here, higher hydrocarbons are converted into lower hydrocarbons are called as pyrolysis. The next important bit among our syllabus is related with the conformation of alkene. What it is? Conformation. Conformation of alkanes. Have you observed, children? In case of alkane, carbon atoms are bounded by single bond. When they are bounded by the single bond, the nature of the bonding will be sigma. Okay, and the sigma bond is obtained by axial overlapping or face-to-face overlapping, which is also called as head-on overlapping. Head-on overlapping, and it is a strong overlapping when two atomic orbitals are going to overlap axially. When two atomic orbitals are going to overlap axially, the strong bond is going to form as a sigma bond. They are going to formed as what? A sigma bond. And here the carbon-carbon bond, single bond, are free to rotate. Have you observed that when the two carbon atoms are bonded by the single bond, we can rotate and we can get large number of rotation because a different angle, if the two carbon atoms are there bounded by a single bond, correct? This is one carbon, this is one carbon. One you can make because for balancing, one hydrogen atom will be surrounded by, one carbon atom will be surrounded by 3 hydrogen. Here, one you make it as a fixed, you go on rotating another one. So we'll get a different forms. Okay, different forms with different angles. Those are called as conformation. Therefore, during the conformation, we can say that as they are going to be around the internuclear axis. So here, force of repulsion can occur between hydrogen and hydrogen. So what we can say that the repulsive force or the repulsive force of interaction between the electron cloud, which affect the stability, called as torsional strain. During rotation, what happened? Hydrogen can come close and they can be away from each other also. Okay, actually the carbon, this one, the carbon-carbon single bond, when we are writing with respect to this one minute, they can come close to each other or they can be far away from each other. If they come close, they are going to form eclipse conformation. I'll show you the diagram also, children. Eclipse conformation. If they are far away, staggered conformation. Staggered conformation, and always eclipse conformation will be less stable, staggered conformation will be more stable, and there are two ways are there to represent conformation. There are two ways are there to represent the conformation. One is called as Sawhorse conformation formula. And another one is Newman projection formula. Newman projection formula. In case of the Sohor's projection formula, we are going to represent the carbon atom with a straight line, with a line. And every carbon atom, this is also a carbon end, this is also a carbon end. Every carbon atom has 3 hydrogen. Because we are going to take with respect to what? Ethane. We are going to take with respect to ethane. You can observe that one you are making fixed, you are rotating other. A different angle will get a different conformer. Amongst those, when they come close, they are called as eclipse conformation. When they are far away from each other, they are called as staggered conformation. Whereas in case of the Newman projection formula, one carbon atom will be represented by a dot. Other carbon atom are represented by a circle. Every carbon atom has how many hydrogen? 3 hydrogen are there. Every carbon atom has 3 hydrogen. How they are going to form different angle? I'll show you children here. Okay, see here. We'll see here, children. Eclipse conform with the diagram, it will be easy for you to remember. Okay, so here what I said that okay, look at over here. Eclipse conformation. Conformation may be eclipse, may be the staggered form. So what I said that when we are writing the eclipse one, a conformation about the carbon-carbon single bond. Single bond we can take here, children. We can take a carbon-carbon single bond. Okay. Carbon-carbon single bond. Carbon-carbon single bond in which the atoms or the single group of atom or the one of the carbon atom are close as much as possible to the atom with the group of the atom which are adjacent. 2 carbon atoms are there. Okay, I'm representing here Newman projection formula. You can see here, this is one carbon, okay, containing 3 hydrogen, and this is another carbon. This is round one. This is another one. Okay, both are containing 3 hydrogen. If they come closer to each other around the rotation, you'll get a different form, different infinite number of probable isomers you'll get. In that, they are selecting only 2, which are stable, which are less stable. Eclipse it is, eclipsed. Eclipsed. And here torsional angle will strain due to the interaction, because repulsive interaction will be there between 2 hydrogen, and due to repulsive interaction molecule will become less stable. That's why what I said, due to repulsive interaction between the 2 electron cloud makes the destability of a molecule or a conformation. That's why molecule will be unstable. They will be what, children? They will be unstable. If I'm going to take with respect to what in the case of this one, the staggered conformation we said. In the case of the staggered conformation, you can see they are far away from each other. Correct? They are far away from each other. I have written both over here. When we are taking with respect to the far away from each other, they are stable. The bond angle is how much, children? 60 degree we said. 60 degree. Here the bond angle is 0 degree. They are very close to each other. That's why they are less stable. these are most stable. Most stable. This is the Sauer's projection formula. During the rotation, you can see over here, as these hydrogen can come close, but they can be converted into what? Far away from each other. One thing you need to remember, that relative stability can be decided on the basis of rotating the angle. On the basis of what? Rotating the angle. Even with respect to dash and the wedge also, we can be able to represent. Next to what we said, that if here we are going to calculate the dihedral angle. As I said already, angle will be 0 degree and the 60 degree for the staggered. That's why far away from each other, we are going to get the angle as 60 degree. With the angle, they are becoming more stable. The last one we said, that how the different projection formula are going to form. Here we are going to get a close to each other, far away, again close, again far away. Like this, they are going to form different conformer at a different angle. One are going to remain it as a constant. You are keeping one as a constant. You are rotating other one. You are rotating other one. Like that, we are going to get a, here we are going to get a staggered conformation, and here you are going to get a all eclipse conformation. All these are staggered conformation. So staggered will be more stable, eclipse will be less stable. Eclipse will be what, children? It will be less stable. That's why when we are dealing with such this one, always you should remember that in what way we are going to decide. In what way we are going to decide. Now the question arises that amongst this one, the question arises with respect to what? Relative stability of staggered and eclipse conformation. This point also important, children. Relative stability of conformers, I can call. Conformers we can call. They of eclipsed conformer or staggered conformer. Staggered conformer, eclipse conformer or staggered conformer. In the case of the staggered or the eclipse conformation, you can observe that one on the other hand, if we are taking the repulsion in the electron cloud, because eclipse conformer, if I am going to represent, they are very close to each other, as we said just now. They are closed. Correct? They are very closed. Whereas in the eclipse staggered conformation, they are far away from each other. All these are hydrogen. All these are hydrogen. We are taking ethane. You can take for propane, butane and all also. So here we can say that when we are dealing with staggered conformation or the eclipse conformation, we can remember that thus the staggered conformation of ethane is more stable because of the energy difference between them will be how much? 12.5 kilojoule per mole. Difference will be 12.5 kilojoule per mole. Less energetic will be more stable, children. This we need to remember. This completes the topic alkane. And the next bit we are having, the next subtopic in our syllabus is alkenes. That also will start, children, because we have to wind up this alkane and alkene both for our this one weekly exam. Alkenes. Alkenes are olefins because those are oil forming unsaturated hydrocarbons with general formula CnH2n. CnH2n. Let us write the example. First member of alkene will be containing 2 carbon atom. 2 carbon atom. First member of alkane family is methane. First member of alkene family is ethane. Ethane, propane, butane, ethene, propene, butene, pentene, etc. The suffix must be ene, children. Suffix must be ene. Suffix must be taken for this one as ene, alkenes. It should be alkenes. Okay. So here in the case of the alkenes, what we have to discuss? What are alkene? How to represent alkene? Their nomenclature, and the most important is isomerism, method of preparation, physical properties, and chemical properties. Here also we are going to discuss two mechanisms. Two mechanisms are there. One, addition of hydrogen halide to the alkene, presence of peroxide, absence of peroxide. Two mechanisms are there. Both the mechanisms we need to discuss. Okay. Here number of reactions are little bit more as compared to alkene, because alkane was paraffin, low reactivity. Alkane was paraffin, that's why it is a low reactive. Nomenclature, when we are dealing with the nomenclature, as you know very well that already we have discussed in the earlier topic. Carbon containing multiple bond will be counted in parental chain. If it is violating the rule also, the carbon-carbon double bond must be counted in parental chain. That we need to remember here, children. For example, if we are going to take the nomenclature, already we have completed offline in the classes. Only few minutes I'll repeat, then I'll go. Carbon-carbon double bond, or the unsaturated hydrocarbon, must be counted in parental chain. Parental chain must be counted in parental chain, and according to the suffix, as we said, that it will be alkene will be the ene will be the suffix. Ene will be the suffix. And in case of alkene, carbon-carbon double bond. Okay, if I am going to take carbon, if I am going to take with respect to the carbon, that is how they are going to be overlap. How they are going to be overlap, we'll see, children, here. Okay, one of this one amongst the px, py, and pz, one of the orbital will overlap axially. One of the orbital will overlap. One of the orbital will overlap, children, axially. One of the orbital will overlap axially, whereas the remaining are going to overlap laterally. Due to lateral overlapping only, there is a formation of what? Pi bond. There is a formation of pi bond. This leads to sigma bond, whereas the axial bonding leads to what? Pi bond. Sideways overlapping leads to pi bond. Pi bond, and the facial overlapping leads to sigma bond. And sigma bond will be strong bond, pi bond will be weak bond. That's why when we are writing the ethene molecule, especially ethene molecule, we'll write carbon with carbon. See here, we are going to take the first member of alkene family. We'll write carbon with carbon, 2 hydrogen are there. Every carbon contains 2 hydrogen. Correct? Electron cloud, because they are having one lobe above the plane and the other lobe below the plane. This will be the simplest way to represent. One lobe will be above the plane and other lobe will be below the plane. These two are the lobe. They are not different. But these two are the lobe, and they are forming the bond angle as 120 degree. Bond angle will be how much? Bond angle is 120 degree. Bond angle is 120 degree. The next important part in this topic is related with what? Isomerism. Isomerism in alkenes. as we know very well that isomerism in alkenes they will show chain isomerism, position isomerism from a structural isomerism. And from stereoisomerism, alkene will exhibit geometrical isomerism. So here alkene will show in a structural isomerism. In a structural isomerism, and even alkene will show stereoisomerism. In structural isomerism, they will be chain isomerism and position isomerism. In structural isomerism, they will show geometrical isomerism. These are the three isomerism we need to discuss in alkene. We need to discuss in alkene that how does the chain isomerism are possible. Similarly, with respect to position isomerism and geometrical isomerism. We'll see one by one, children. Let us move to chain isomerism in alkene. Chain isomerism in alkene. Chain isomerism. Name itself indicates that two or more alkenes, it is the phenomena in which two or more alkenes having same molecular formula, but they are differ in carbon chain, arrangement of carbon chain or parental chain are different. Parental chain will be different, or we can say that arrangement of carbon chain will be different. They are called as chain isomerism. They are called as what? Chain isomerism. If I'm going to write, for example, CH3, CH2, CH2, CH, double bond CH2. This is carbon atom number 1, second, third, fourth, and fifth. Correct? Pent 1-ene. We can write its chain isomer without changing this position. This will remain as it is. Correct? But here at this carbon atom, methyl group can be written 1, 2, 3, 4, and 5. So parental chain will be 1, 2, 3, and 4. 3-methyl but1-ene. 3-methyl but1-ene. So it means that double bond position is between 1 and 2 only. Double bond position should not disturb, but parental chain should be disturbed. Same way you can try for writing 6 carbon atom, 7 carbon atom, 8 carbon atom. You go on trying for the molecule for the carbon atom in such a way that double bond position will be same, only the change of what? Parental chain. Parental chain. But molecular formula will be same. 1, 2, 3, 4, 5. It also contains 5 carbon atom. 1, 2, 3, 4, 5. It also contains 5 carbon atom. This also contains 10 hydrogen. This also contains 10 hydrogen. Hydrogen atoms will be 10 and 10. But where they are differ in what? Arrangement of carbon chain. That's why these are called as chain isomer. So chain isomer, while writing the chain isomer, we can say that number of carbon atoms in the parental chain will be different. In the parental chain will be different, but molecular formula will be same. Molecular formula will be same. So in the next way, we will write position isomerism. Second one, position isomerism in alkene. Position isomerism in alkenes. Position isomerism means what? Position of multiple bond will be different. Multiple bond. Molecular formula will be same. Molecular formula is same, but position of multiple bond is different. Is different. CH3, CH2, CH, double bond CH2. Double bond is present between 1 and 2nd carbon atom. It may be possible that double bond can be shifted between 2nd and 3rd carbon atom. Carbon atom number 1, 2nd, 3rd and 4th. But 1-ene. It is called as what? But 1-ene. But 2-ene. So here carbon-carbon double bond position will be different. That's why they are called as position isomerism. They are called as what? Position isomerism. Therefore, in the chain isomer, parental chain will be different. Whereas in position isomerism, position of multiple bond will be different. The next part in this is related with stereoisomerism, that is geometrical isomerism. As we said already that in the earlier topic, 2 or more molecules having same molecular formula, but arrangement of atoms or molecule in a space is different. They are called as stereoisomerism. Let us move to geometrical isomerism in alkene. Geometrical isomerism in alkene. It means that carbon-carbon bonded by multiple bond. Correct? One will be sigma bond, other will be pi bond. Carbon-carbon double bond rotation is restricted. Rotation is restricted. And that restricted rotation arises geometrical isomerism. Therefore, there are two conditions. There are two conditions for a molecule to show geometrical isomerism. First condition, that carbon-carbon double bond must be present. Bond must be present. Important note, children. Sentence you read properly, necessary to make the note, then go on solving. So here carbon-carbon double bond must be present. And the second, that in carbon-carbon double bond, here P and Q, A and B, something will be linked. Correct? These bounded atoms must be different. Okay? Two bounded atoms to each carbon atom. Two bounded atoms to each carbon atom. Means individual carbon atom. You think of individual carbon atom. Must be different. Different. This is called as geometrical isomerism. So here in the geometrical isomerism, molecule should contain carbon-carbon double bond. It contains carbon-carbon double bond and the two bonded atoms must be different. For example, if I am going to take carbon-carbon double bond, one is a hydrogen, another one is a methyl. Correct? One is a hydrogen, another one is methyl. Double bond is also there. And here two bonded atoms are different. If these two bonded atoms are lying on the same side, it is, what is the name? Tell me. 1, 2, 3, 4. But 2 ene. If the two are lying on the same side, they are called as a cis isomer. Cis isomer. If they lies on the opposite side, H, CH3 and CH3. If they lies opposite side, okay, this side and this side, they are called as a trans isomer. Here also same way. They are different. They are called as trans 2-butene or trans but 2-ene. Trans but 2-ene. 2-ene. Difference or the stability between cis and trans isomer, everything will see, children. So here cis and the trans isomer, when we are dealing with the cis and trans isomer will be less stable, whereas a trans isomer will be more stable. Because of the hindrance, molecule are far away from each other, less chances of getting what a hindrance. Hindrance are nothing but presence of bulkier group. Here two bulkier group are on the same side. They are getting a chances of what a hindrance. They are getting a chance of what a less stability. Therefore, trans isomer are more stable. More stable. And the cis isomer are less stable. Less stable. Correct? More stable and the less stable. Still with some more examples. Just to go through this one, whatever we have covered, children. In the next class, again, we'll continue. Okay, we'll wind up here. Whatever I have covered, once you go through it, children, if any doubt are there, just you can post your question. And after posting the question, wait for the minute because we'll be busy with the classes or some other schedule. That's why as soon as I'll get the time, I'll reply your answer. Okay, thank you one and all.